Hello and good afternoon, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the Cisco Networking Academy CCNP route course, and we're going to be taking a look today at a video tutorial here on challenge number 6 out of the Cisco Learning Labs. Again, another fantastic opportunity to allow us to sort of stretch our OSPF legs here. So let's take a look at the optimization tasks that we're going to be required to do here. And you can definitely infer from optimize that we're going to be doing some summarization. We're probably going to be doing a default route. Again, we've got the same sort of network setup that we had before with challenge number 5, but now we get some different tasks. So the first one is establish connectivity in the leaf areas and ensure that the non-backbone routers dist and BR for branch, so distribution and branch, can communicate with IP addresses in the OSPF domain. And then we have here, we're going to advertise a default route from the internet gateway, and that's the server here, this router here, GW, and ensure that all OSPF routers can reach the internet address 209.165.201.1. Don't configure any additional static routes. So here is the restriction, is that we cannot configure any additional static routes or additional IP addresses on the gateway router. So this is definitely a indication that we're going to use that default information originate always. So in fact, let's go ahead and let's jump onto the gateway router and let's take care of that right now. So we'll go from user exec to privilege exec into global config. And if I say do show run, and let's see if there's a section OSPF. Let's see if we have any configuration. Well, we do. We have a substantial amount of configuration here. In fact, we've got a redistribute connected subnets route map that is also in play here. So we're going to go ahead and say router OSPF1, and we already know that we're going to say, sorry, not redistribute. So we're going to say default information originate, and we want to make sure that it's always. And what that always means is that even if I don't have a static route configured for the default route, I'm going to go ahead and still into the OSPF domain advertise myself as a default gateway. And so we'll say default information originate always, and we'll leave it at that. So we've just addressed this one here, very low-hanging fruit, so kind of easy. So summarize the external networks advertised by BR, or the branch router, using the smallest possible address block that covers all individual subnets. Well, let's go ahead. Let's tackle this one right now. We'll have to pull I believe in order to see what we're looking at here, we've got those external networks. So we may or may not need, let me read this again here. Let's make sure, summarize the external networks advertised by the branch. So let's pull that branch router up. Looks like we've got 4 loopbacks, probably the same as we saw in challenge activity 5. So we'll go from user exec to privilege exec into global config, and I'll say do show IP interface brief. So we're interested in the external networks, and when we take a look here, here is our set of external networks. So it looks like the first 8 bits and then the first 16 bits, 172.31, these appear to all match. So we've got 16 bits that match already, but now we've got this interesting hextet here. I'm sorry, octet, scooping into IPv6. So we've got this interesting octet here. So 64 would be 0, 1, and then all zeros, 1, 2, 3, 4. And then 64 again, 0, 1, 0, 0, 1, 2, 3, 4. And then we've got 65, 0, 1, 0, 0, 0, 0, 0, 1. And then we have 127, which is going to be 0, 64, and 32 is 96, 112, 120, 124, 25, 26, 127. So this is equal to 127. Whoops, sorry about that. Pin is a little jumpy. And again, this was 65, this was 64, and this was 64. And so now when we take a look at this, we're going to walk through and we're going to say which bits match and where does it stop matching. Well, we can clearly see that after those first 2 bits there, it no longer matches, and that bit value, which is 64 in this column here, that bit value is actually on. So if we were to go ahead and calculate what we would have here in terms of the subnet mask, it would be a 255.255 dot just these, and actually those two values, no, those two values are definitely not on. So 255, 255, and then 192 dot zero, and actually, no, hold on a second. I think I've got this backwards. Yeah, it's not going to be 192. It should be 64 because this bit position is off in both of those. Although, oh, I'm sorry, the 2-bit positions match. Yeah, I'm making this more difficult than it needs to be. I was thinking of the IP address, not the net mask. So the net mask is 192 because we've got 2 bits that match here, 128 and 64, and that's going to equal 192. And I'm sorry, I was looking at the 64 here, and then I looked over here thinking it was the IP address, and it's not. So my IP would be 172.31.64.0 slash, and it's going to be 16.17.18, which would be the 255, 192.0. And that's going to be the most restrictive summary that we can configure. So let's go ahead, clear the screen now, and actually, yeah, so I'll be able to remember that. I hope. All right, should be able to remember that. All right, so we're on the branch router, and the branch router is going to be where we configure this. So we're going to say router, and actually let me do a quick do show run and pipe it to section Ospf. So we've got our router ID, we've got a redistribute connected subnets. So if I were to say do show IP route Ospf, well, we don't have anything right now. We may have to do some troubleshooting here to figure out what could be wrong there. So, but let's go ahead and go into the router Ospf 1. Yep, router Ospf 1. And we're going to go ahead and enter in our summary, or actually, it wouldn't be a summary address. We're going to end up saying, yeah, so is it going to be a summary address? Yeah, so we're going to summarize these external routes. So we'll say summary address 172.31. I keep thinking for some reason these are internal routes. .0, 255, 255, 192.0. All right, and so that gives us the summary that we're looking for on the branch router. And again, remember that the branch router has these external networks that have been redistributed in. And so for the external routes, we don't do an area range, we do the summary address command, because again, this is an ASBR, right? So on the branch router, if I were to say do show IP Ospf, it should say, and there it is, and I found it much quicker this time. I think I've looked past this a couple times here. What is this router? It is an autonomous system boundary router. It is an ASBR. And so on the ASBR, we issue underneath the Ospf configuration section summary-address. And this is different from when we did the summary address on the ABR, where we would use the area 1 range, whatever area, I'm just saying this is area 1, range, and then I would put in the IP address and the subnet mask, right? Okay, so we go with the summary address command because this is an autonomous system boundary router. It is not an ABR. It is an ASBR. So we use this summary address command here to perform our summary. Okay, so we've got that summarized. Let's confirm. If I go here to the gateway router, let's see if we see anything. And if I say do show IP route, and we don't see anything, so there could be some extra work that needs to be done. Let's take a look here. So we summarize the external networks by advertising, or having the BR router advertise the smallest possible block, reduce the Ospf routing table and database in area 1 as much as possible. So let's check out area 1 here. Actually, excuse me, we'll need to take a look at our job aids. And so area 1 is actually these routers here, HQ1, HQ2, or these, I should say, these interfaces on these routers, and the distribution router. And let's go back to the scenario here and let's see where we're at. Make sure that traffic from and to area 1 flows in both directions over the same ABR. And so this is where we're going to take a look at a little layer 3 traffic engineering. All right, so here's what we're going to do. We're going to start on the, we'll take a look here at the distribution router in area 1. Let's see how this is configured. We'll go from user exec to privilege exec into global config, and I'll say do show run section Ospf. Let's see what we've got configured. All right, well, we can see we already have some IP Ospf hello intervals that have been set on at least 2 interfaces, and we should immediately recognize that this could be an issue. If I say do show IP Ospf neighbors, we have no neighbors. So remembering that the hello interval needs to match, let's say do show IP interface brief. So my guess would be is that that hello interval has been set on Ethernet 00 and Ethernet 01. Let's take a look. Do show run in Ethernet 00. Do show run in Ethernet 01. And what do we have? We've got that IP Ospf hello interval 20 has been set on both of those interfaces. So what we need to do is we need to confirm, I'm taking a look at the diagram here, if both of these interfaces have the hello interval set to 20, then that would mean that on HQ and on the HQ2 Ethernet 01 interfaces respectively, we would need to make sure that that matches. So before we do anything else, let's go ahead and say do debug IP Ospf adjacency. And let's see if the distribution router is going to give us any information with respect to the adjacency. And in fact, let's not only debug the adjacency, let's debug the hellos, because it's in the hello packets where we're going to have that, where we have the hello interval and the dead interval. And sure enough, you can clearly see here that we're getting a message, mismatched hello parameters from 172.16.24.2 and 172.16.14.1. And so every 10 seconds, we're probably going to get a flurry of messages telling us that the hello packets are mismatched. All right, so now that we know that those are mismatched, let's go ahead and pull up HQ1. And let's take a look here. We'll go into privilege exec and in the global config do show run section Ospf. So it doesn't appear that the hello interval is set anywhere here, right? So we've got 2 choices. We could set the hello interval to 20, and that wouldn't be a problem, right? We could certainly go in and do that, or we could remove it from the distro router. Well, let's go ahead. We're going to play along here. We'll say interface Ethernet 01 IP Ospf hello interval 20. And what we should see, if that is the only problem between the HQ and dist routers, is that excuse me, is that the adjacency should form. So let's see if we're still getting the mismatch hello. So we're seeing it from router 2.2.2.2 area 1, and there we go. We've got a what appears to be an adjacency establishing. Let me come back over. It's a little crowded here, and there you go. So that was basically one of the first issues there, was that the hello interval was wrong. So let's fix it again, and actually let's fix it again on HQ2, right? So we're here on HQ2. We'll go from user exec to privilege exec into global config interface Ethernet 01 IP Ospf hello interval of 20. And so we'll set the hello interval to 20, and what we should see is an adjacency is going to form here with the distro router. Let's make some space here because we should see a flurry of messages within the next 10 seconds. And the hello packets are going to be flooded out to the multicast address 224.0.0.5, and there it goes. And you can see we've got our database descriptor packets, our link state updates, our link state requests, right? We become fully synchronized and we go from the loading state to the full state, right? So if I come over to HQ2, you can see we now have an adjacency there because we went ahead and we matched the hello interval. Now, again, the other way I could have done this, which you may think might have been easier, and again, as long as it's working, that's the most important thing. So I went ahead and matched the hello interval instead of saying no IP OSPF hello interval on the distribution router. So now let's go ahead and check here. From the distribution router's perspective, let's say U all for undebug all. And I'm going to say show IP OSPF neighbors now, see which neighbors we have. So we've got router 1 and router 2, or HQ1 and HQ2, and we are in a full, and we see router or HQ1 and HQ2 as BDRs. The dead time is right around a minute, and well, that's actually fluctuating. Then we've got the IP address that we can reach those neighbor OSPF neighbors on, and then the outgoing interface out which I can reach those OSPF neighbors. So if I were to say show IP OSPF database, what do we see? So take a look at what we see here. Do you see the advertisement yet for the Type 5 external, the summary, those redistributed routes that we tried to summarize? I don't see those here, right? So we'll work our way down to the branch router and try to figure out what's wrong. But what do we have? We've got the default route. We have these two routes which have been created on the gateway router, which are sort of simulating internet connectivity. We have our type, this is our type 4, right, for our ASBR. So this is my summary ASBR, which shows the link state ID is the router ID of the ASBR. And then OSPF is going to tell me you can reach that ASBR by not traversing, like completely missing the word, by recursively finding your way to either router 1, HQ1, or HQ2, because they know how to get to this ASBR. So then I would check to see, do I have a type 1 LSA for either router 1 or router 2? And when we look here, you can see that I do. Right, so these are my type 1 LSAs. These are the router LSAs. Here's my type 2. And this is the link state ID for the type 2s is what? Whose IP address? You've got it. That is the designated router address right there. And the advertising router is router 4, whom I believe is this distribution router. So how would we confirm to see if the distribution router is in fact router 4? There's a couple ways I could do it. I could just simply say show IP OSPF, and the router ID, show IP OSPF, or show IP protocol, sorry, show IP protocols, and the router ID shows up right there. So router ID 4.4.4.4, and then we see we've got a passive interface on loopback 0 on that distribution router. All right, excuse me. So let's go ahead and make our way over to, we've kind of done some good work here on the distribution router. Let's take a look on the HQ1 router. So if I were to say do show IP OSPF neighbors, you can see that I've got a neighbor relationship with HQ2, the branch router, and then the distribution router. However, let me take a look at the diagram here. So I've got 1, 2, 3. So let's take a look at HQ1 and say do show IP protocols. All right, so passive interface is just the loopback interface, and we're routing 4 networks. Let me say do show IP interface brief. Let's make sure that those statements are all correct. 172.16. .123.1, 172.16.14, so that looks good. And let's say do show run section OSPF. All right, so we set the hello interval there. And do show IP, IP OSPF neighbor. All right, so HQ1 has a full adjacency with the DRs and the BDRs on its respective segments. Do show IP OSPF interface brief. And it should have a single interface, Ethernet 01 in area 0, and then two interfaces in area, in area 1 it has a single interface, and then two interfaces in area 0. So that looks good. So let's go over to HQ2 and say do show IP interface brief, and do show IP OSPF interface brief. All right, so we've got that single interface in area 2. That's good. Area 1 has a single interface, and then we've got two interfaces in area 0. All right, so that actually looks good. Let's say do show IP OSPF neighbor. Aha! So when we take a look at the show IP OSPF neighbor, you can see that everybody's full except with router 5, it appears to be stuck in the two-way state. Now, this is indicating a priority of 0 is indicating that that's a point-to-point link. However, if I were to say do show, if I were to say do show IP OSPF interface, let's take a look at that Ethernet 02. All right, so here is Ethernet 02, and this is definitely a broadcast segment. And so my gut is telling me that, let's see, who is router 5? So if I'm on HQ2, is it the gateway router? Let me check really quick here and see if the gateway router show IP protocols. No, the gateway router's 3. Is the branch router 5? Show IP protocols. Aha. So the branch router is router 5.5.5.5. And the HQ router, as it did in the previous activity, clearly sees that as a broadcast network. However, do show IP OSPF neighbors is saying that we're kind of stuck in the two-way state. So if I were to say, let's see if we see anything. Do debug IP OSPF adjacency, and let's IP OSPF hellos. Let's see what we see here on HQ2, if it gives us any information or if it's just going to tell us. So it's sending the hellos, and do we see, so yeah, we're receiving hellos, from the branch router, and we're sending hellos. However, we're still in the two-way state. All right, so let me say do you all. I'm not seeing much other than that. So let's say do show run interface Ethernet 02. Aha. So do you see the problem? So that priority setting of 0, if I come over here to the branch router, my guess is going to be show excuse me, show IP OSPF neighbor. What is branch, or the branch router see from router 2, which is HQ2? It also has a priority of 0. However, this is not a point-to-point network type. So if they're both set to 0, then there's not going to be a DR BDR election. So let me do this. Let's say debug IP OSPF adjacency. We're going to go into global config, interface Ethernet 00, and I'm going to say shut. So we're going to shut that interface down, and then I'm going to say no shut. And let's see if we get any indication. All right, so two-way communication. The state is two-way. Interface came up. And then, as you can see, it just kind of stops at the two-way state. And the reason is we've got a priority of 0 on one side, and we have priority of 0 on, is it both sides? I think we have it on both sides. So show run int Ethernet 00. So yeah, so the priority's been set to 0 on both sides. So let me see. I want to see debug IP OSPF. And we should have database timer events flood. Hello. Yeah, so there's no end of wait. So yeah, so take a look at the problem, right? So I'm glad that I waited that out for the timer to time out there. So what's the problem? We're on a broadcast segment, and what do we need to have on a broadcast segment? Well, we need to have a DR and we need to have a BDR. And unfortunately, when both of these values are set to 0, that is not going to happen. So you can see, do we elect who's the DR? None. Who's the BDR? None. So this is a problem. Now, there are a couple of ways, I believe, that we could get around this. So let's do the one way that I'm thinking of here is obviously not going to be the conventional way to resolve this issue, but we're going to give it a go here. So if I go into interface Ethernet 00 and I say IP OSPF network, oops, point to point, aha, interface going up, sending a database descriptor packet. So now let me go over to HQ2 and say the same thing on interface Ethernet 02. I'm changing the OSPF network type. So, and what am I changing it to? An OSPF network type that does not require a DR, BDR election. And take a look at that. So this is probably definitely not the conventional way to resolve this issue. However, if the restriction said that do show run interface Ethernet 02, if you had a restriction that said you cannot change any of the interface settings between the two routers and you need to get the OSPF adjacency up, then this is a great way to do it, is to simply set the IP OSPF network to point, right? And then it's going to go ahead, and if I were to say do show IP OSPF, and actually did it, yeah, so you can see we are fully adjacent here, and the priority of 0 is okay when it's a point-to-point network. So let's go ahead, we'll take that out. We'll go ahead and say Control A, I'll say no, and it'll do the countdown to extinction here, right? And if I come back over to the, is it the dish? No, I'm sorry, HQ2 and branch. If I come back over to the branch router, let's go ahead, we'll pull that command off as well, and I'll say no IP OSPF network point-to-point. And so, again, you can see we're kind of going to get stuck in two-way. Do show IP OSPF neighbors, and again, the priority is still 0. Do show run interface Ethernet 00. So there's that IP OSPF priority 0, which kind of got replaced when I put in that IP OSPF network type point-to-point. The priority 0 went away. Why do you think it went away? Because that's the default for point-to-point networks. So that's why the command disappeared, is because for point-to-point networks, the priority is 0. So it's not that we removed that command. That command was still there. It's just that now that we've got it set as network type point-to-point, the command's not going to show because that's the default setting for that type of OSPF network. So again, that was sort of the unconventional way, maybe an outside of the box type approach. But again, if you were given the a restriction that said that you can't change the priority value. Let's say that's probably a better way to put it. That you can't change the priority value. You have to leave it at 0. Well, then let me, when given lemons, make lemonade. All right, well then let me think of a network type where I don't need to elect a DR and a BDR, and the priority can be 0. And that's our point-to-point network type. So that was a great way to maybe work around it. Now, obviously, the easier way to do this is going to be to say IP OSPF priority. And I'll go ahead and we'll say that we'll make the branch router 254, and then I'm going to come over to the HQ2 router and say IP OSPF priority 255, right? And they should both go from loading to full, and do show IP OSPF neighbor, and we're perfectly full, and we see the branch router as the DR because that was probably the one that we first kicked the priority command onto. Shows the priority of the DR as well is 254. Shows it's router 5. We are full. It's a DR. There's our countdown timer from 40 seconds for our broadcast network. This is the IP address of the neighbor out the local interface Ethernet 02. All right. So let's clear the screen there. So we took care of that. So now establish connectivity through all the leaf areas. Let's see here. So we should have connectivity when I'm looking at this diagram here. All right, so let me take a look at the branch router, and let's say do show IP route OSPF, and perfect. All right, fantastic. So we're picking up that default information originate always, right? So we're going to go to router 2 to get out of this network. So let me check here. Let's see. Do I have connectivity? Whoops. Do I have connectivity from this leaf node? So if I were to say do ping, and what's the address we're trying to reach here? It says 209.165.200.1. All right. So not so fast. So we're getting a U, which is the destination unreachable, when we try to do our ping. So again, I'm able to, I should say I'm not able to. I don't have connectivity. Let's check from the distribution router. Do we have connectivity yet? So we'll get into privilege exec and say ping 209.165.200.1. Aha. And again, I don't have connectivity all the way through. So let's take a look over here, and this may be where we come down to. So reduce the OSPF routing table and database in area 1 as much as possible. So let me take a look at the job aid here, and let's see area 1. We want to reduce as much as we can the database here. So what this is probably looking for us to do is to set this area as totally stubby, and or stub or totally stub. So yeah, let's do totally stub because that's going to be even more advantageous. So let's get on to HQ1 here, and we'll go into privilege exec and into global config, and I'll say router OSPF, and let me check to make sure it's process ID 1. Do show run, pipe it to section OSPF, and yep, it's router OSPF 1. So router OSPF 1, and I'm simply going to say area 1 stub no summary, right? And that makes it a totally stubby area. If I pulled back the no summary and left it as area 1 stub, that would be creating a stub area. When I say no summary, I'm making it a totally stubby area. And let's see how this is going to impact area 1 here. So I'm going to do that on HQ1. I'm going to do the same thing on HQ2. So we'll say do show run section OSPF. Whoops. All right, so we've got router OSPF1, router OSPF1, and we're simply going to say area 1 stub no summary, right? And so what we've done is for area 1 on these interfaces here, we've said stub no dash summary, right? And that's what we've done on these interfaces here. So now the final thing we need to do is we need to get down to the distribution router, and we need to do the exact same thing on the distribution router. We'll get into global config router OSPF1, and I'm going to say the same thing, area 1 stub. Now, this is interesting, right? So I can put no summary, and it's not going to break anything. It's going to do exactly what it's supposed to do, but I don't have to, right? I don't have to put stub no summary because it's being done on HQ1 and HQ2, who are my only paths out. So, and in fact, you can see here the dead timer just expired because we are not the right area. So let's go ahead. If I were to say do debug IP OSPF adjacency, let's see if we see anything that's going to indicate that we have a mismatch in the network types. So HQ1 and HQ2 are set to be totally stub, and I'm simply set to be a normal router in area 1. And I haven't been set to a stub. So it looks like we've got a DR election do show IP OSPF neighbors. Let's see what it looks like. We've got no neighbors, right? So what we need to do here is, again, area 1 stub. And again, I can say no summary, right? But you don't have to on the router that is inside the area without interfaces to the outbound networks, right? So because again, HQ1 and HQ2, they're ABRs, they're in multiple areas. Dist is only in area 1, so he is going to be our stub. Now this is going to bring up the adjacencies that we're looking for, and that actually was pretty quick, right? Because now the stub area types match, right? So when the stub area types match, the adjacency will form. So if I say do show IP OSPF neighbor, and actually get all that output out of the way there. And is it going to keep showing? There we go. All right. The 2 times I did that command, it kicked up the DR BDR election debug output. So do you all? We'll stop the debug there. All right. So now I'm full to router 2 and router 1. And the distribution router sees both of those as BDRs. And let's see. Hold on. Yep, sees both of those as BDRs. All right, out both interfaces. So now the requirement was to clean up, I guess in area 1, to clean up the OSPF database and the routing table. So did we achieve that? So do show IP route. We'll take a look at that. So now we've made it a totally stub. And we said no summaries. So what do you not see here? In the routing table output, there are no type 3 LSAs in here at all, right? None. With the exception of our default route, which is automatically flooded into area 0, right? And so the dist router is going to see that his default route can take him one of 2 directions, right? So we've got some equal cost load balancing in here because, again, the administrative distance of OSPF is 110. Our metric is 11, right? And so we've got equal cost paths to the default route, which means if I was to clear the screen here, and if I was to say do trace to 0.0.0.0, let's see if that actually, yeah, that's not going to work. So do trace, and we'll trace out to, let's actually do the 209.165.200.1, I believe is a legitimate address. So you can see how quickly, right there, it load balances over the multiple paths, right? So the first 3 packets that go out goes to router 1, router 2, router 1, and then it goes up to 16.123.3, which is probably that interface there. And then again, it's kind of like there's a little loop of some kind here, right? Or we've got something's wrong getting to that IP address. So let's clear the screen here, and we'll continue to troubleshoot. Let's make sure that we have covered. All right, so make sure that traffic from and to area 1 flows in both directions over the same ABR. Well, we kind of took a look at that earlier in activity 5, right? What's one of the ways that we addressed the issue when we were saying we want the traffic from the distribution router to flow this way as opposed to going that way, right? Well, we got in there and we manipulated the OSPF cost. So if I want to make sure that all traffic leaving the distribution and going to the same ABR, and we'll go ahead and say we'll use HQ1. That is going to be the ABR all traffic goes out. Now, we also want to make sure that that's the route all traffic is coming in, right? So we're going to have to make this path right here, these two interfaces, look much worse than they do. And this is where the IP OSPF cost is going to come into play, right? So we're going to be manipulating Ethernet 01 and Ethernet 01 on the distro router and the HQ router. So let's go ahead and clear our screen, and let's get onto the HQ2 router. And we'll say interface Ethernet 01, and I'm going to say IP OSPF cost. Now, it doesn't tell me that the cost has to be super close to the other cost, so I'm going to say 9999. Let's go down to the dist router and say do show IP interface brief, and we are looking at, and I can't remember, I apologize, let me take a quick peek here. Yeah, Ethernet 01 as well on the distribution router. So I'm going to go into interface Ethernet 01 and say IP OSPF cost 9999 so that cost matches. So now from the distribution router, if I say do trace to, and actually we should have that queued up in here. There we go. Let's trace out to that 192.165. And actually it's 201. I apologize. I've made that mistake in Challenge 5 as well. To 2011. And where does all my traffic go? Right? It goes out HQ1. Now, what about on the way back in? If I come up here to the gateway router and we get into privilege exec and I say show IP show IP route OSPF, we have a loopback interface, loopback 0. Let's take a look and see what that is. 192.168.4.4 is loopback 0. So on the gateway router, what is my path going to be from the gateway? So I've got 192.168.4.4. I'm learning it as a type 3 OSPF inter area route. My next hop says go to 172.16.123.1, and my guess is there's my .1. It's going to be the HQ1. So now let's step over to HQ1 and see what it feels will be the best path to do show IP route OSPF. So obviously, to get to that 192.168.4.4, we have an intra area route, because again, from the gateway's perspective, he's looking at it from area 0. So he's getting an OIA route here. HQ has an interface in area 1. So this is going to come in as an, I shouldn't say come in as, it's going to be seen as an O, right? An intra area route, because again, this route is in this area, and this ABR has an interface in this area. So we see it as a, I'm sorry, not a 0, as an O, an intra-area route, right? And who's my next hop? 172.16.4.4. Now the final check here, so we know coming this way it's going to go here and then come down. We know from HQ1 it's going to come straight down. We know that distro is going to go out through HQ1. However, what's going to happen over here, right? Because again, HQ2 is directly connected here to the distribution router. So what may happen is it may decide I'm going to come this way, and you know what? That's the shortest path for me. So let's check that out. Let's clear the screen. Let's come over to the HQ2 router, and on HQ2, let's say do show IP OSPF interface, do show IP route OSPF. And how am I going to go to the 192.168.4.4? And it says I'm going to take 172.16.24.4. So HQ, right, says I have an intra-area route, an O route, that will take me down to 172.16.24.4. And this is what I had referred to earlier, is that he's probably not going to go that way because, again, he has an intra-area route going this way. So even though we've set the interface costs here to 9999, it still likes that path coming down this way, right? So if HQ2 says, hey, I'm coming this way to get there, because it's not going to take an inter-area path when it has an intra-area path that it can go through, right? All right, so let's go ahead and clear the screen here, and let's see if HQ2 sees it that way. Then that definitely means that the branch router is going to see it the same way as well. So on the branch router, we'll get into privilege exec, into global config, and we'll say do show IP route OSPF. And so obviously the branch router, he's only got one option for getting out of there, and that is going to be, where's my 192.168.4.4? It's this guy right here. He's got the cost, right? But he's going to router 2. He's coming to this interface here out of area 2, but we already know that once HQ2 gets it, it's going to come this way. So is there anything that we might be able to do to resolve this? And thinking about the, again, we want to lower the cost of how things look from the HQ1 perspective, because we're saying that we want all outgoing and all incoming traffic to come through HQ1 to get to the distribution router. So let's go back over to HQ1, and what we're going to do is we're going to go ahead and let's see, how are we going to deal with this here? This is going to cause me to think a little bit. So we've already manipulated the router. Let me make sure it says both ways. Make sure that traffic from and to area 1 flows in both directions over the same ABR. So it, you know what it might be here, and I'm actually starting to wonder if that is what they're kind of forcing you to. Okay, so we're not going to be able to get it to have HQ2 send it to HQ1 because of the fact that we've got, it's not going to, it has an interface, HQ2 has an interface in this area, so it sees it as an O, an intra-area route. To be able to send it that way to router or to HQ1, it would have to prefer the inter-area, the OIA, over the O. And it's not going to do that. In fact, you can see how poor the metric is, right? It's 10,009. And that is way more than what the metric would be for the inter-area route. But it's not, oh, actually, I'm sorry. That is, I'm on the wrong router here. I'm on HQ1, and I'm looking for 4.4. Yeah, so it's going to look low here. If I went over to HQ2, let's go over to HQ2, we can see that, here we go. We can see the cost of the route from HQ2's perspective is 10,000. And that is ridiculously high given the environment that we're in, but it sees it as an intra-area route. And remember what I said, intra-area will always win out over inter-area, will always win out over, now I'm drawing a blank, I believe it's the E1, yeah, I think it's E1 over, whoops, E1 over N1, and then E2 over N2, right? And so when OSPF is making its path selection criteria, remember that that is the criteria that it's going to use, is intra-area over inter-area over E1 over N1 over E2 over N2. And we've run into that scenario right here, right? Where I have an intra-area route, and again, with a metric of 10,000, which is terrible, because look at these other routes here. Right? 11, 20. And this one is bad because we've set it on both sides. Or did I put it on the wrong? interface. Let me double check and make sure that I've got this on the right interface, because it sees that as an, oh, it sees it as an intra. That's right, because it's in area 1, and right, the cost has got to come out through that interface to get there. So that's correct. So again, that's what we're running into here, is we've got this intra-area route, and we're trying to force the traffic not to come back in over this link and to go into the backbone area and then back down. That is not going to happen because we're learning this route as an intra-area route. So here's what I'm going to do. We're going to flip the scenario, and we're going to force all traffic to come in through HQ2, which should be the method we would want to use. So let's give that a try. So what do we need to do to solve that? So the first thing we need to do is say no IP OSPF cost 9999, and that's on HQ2. I'm going to go over to the distro router, and we're actually just going to change the cost on the distro router. I'm going to say IP OSPF, or no IP OSPF cost, sorry, no IP OSPF cost 9999. And we're going to jump into interface Ethernet 00, and we're going to say IP OSPF cost 9999. And then we'll do the same thing on HQ1's Ethernet 01 interface. IP OSPF cost 1234. And there we go. So now what we've done is we've basically just modified it. We took the statements off of these Ethernet 01 interfaces and we've put them here. So the two statements that we have here are IP OSPF cost 9999. Right? So this link right now should look absolutely terrible with respect to OSPF. So, and I didn't want to clear my screen there. Sorry. So let's leave that here. IP OSPF cost 9999. All right. So now let's go back to the gateway router, and I apologize. I was making the assumption that they'd want this to all be coming through HQ1. So now on the gateway router, we'll get into privilege exec, and I'll say show IP route OSPF. And that 192.168.4.4, we're learning it as an inter-area route, but who are we going to now? We're going to router 2 to get there. Because router 2 only has a cost of 21, right? And based off the cost values that we've got filled in here, the cost outgoing interface here is going to be 999, and then the outgoing interface here is going to be 10. So that's going to take it to 10,009 from the gateway router perspective. So 21 is definitely less than 10,000 and 10,009. All right, so let's go ahead and clear that there. So we'll leave the cost statement there. So now let me come down to HQ1, and let's see if we don't run into the same issue that we had over on HQ2. So do show IP route OSPF. And what is the cost for the 192.168.4.4? As you can see, it has the cost at 10,000, right? $999 for that outgoing interface, and then plus 1 for the loopback, and it's taking the path through router 1. So again, if the traffic reaches router 1, it's going to come this direction. However, the gateway router is going to send everything this way. Let's see. So we already have it set so that all traffic is going out HQ2. If it's destined to the gateway router, it's going to come back in HQ2. Let's check from the branch router and see what direction it's going to come from there. So let's get over to the branch router. Show IP route OSPF, and it should take us obviously to router 2 because that's our only path out of there. Right, and you can see right here, 172.16.25.2. That's router 2. So then the final thing we need to validate here is let's jump on HQ2 and see what direction HQ2 is going to go. So if I were to say do show IP route OSPF, HQ2 is obviously going to take that 172.16.24.0. So all traffic that's leaving the distribution network is going to transit HQ2, and all traffic coming back in from both the branch and the gateway router in area 0 is going to come back in through HQ2 as well. Now, one thing that we could also do is we can configure the default route to give it a different metric. As you see, the metric is 1 right now, right? And so I was just realizing here the metric is 1 on HQ2, and on HQ1 it is also 1. So what we could do is we could also make the default cost on HQ1 look worse as well. So I could say router OSPF 1 and then say, area 1. Area 1 default cost, and we'll make it 88888, right? So now that's what the default route will look like to the distribution router. If I were to say do show IP route OSPF, you can see that which one am I going to choose? Well, obviously I'm going to choose router 2 because all the distribution router has for OSPF routes is that single default route. Because remember, we did a totally stubby area for this exercise. So in looking at this, I think that is everything. Let's take a look back at the scenario. I think we've met everything. Establish connectivity in the leaf areas to ensure that the non-backbone routers can communicate with IP addresses in the OSPF domain. So again, if I were to come to the branch, and let's make sure we ping the right address here, 209.165.201.1. That's perfect. I've got connectivity. How about from distribution, where we are a totally stub? Do ping 209.165.201.1. And we've got connectivity, so we're good there. We've advertised the default route from the Internet Gateway. We've done that. We've summarized the external networks. And so that looks like that is it. All right, so this is going to wrap up. This is a great activity here. This was actually a little difficult from a challenge perspective. So optimize OSPF. We had a lot of work to get done, and we actually went ahead and walked through a series of debugs. Right, we caught some mistakes that we had to troubleshoot, which were the IP-OSPF hello interval being set on a couple of the routers. We took a look at a couple of ways we could have fixed that. We saw that the priority was also set incorrectly on a couple of routers. We saw a couple ways to configure that. We looked at that default information originate always. We set the default cost of the HQ1's default route to be much worse than HQ2, and we went ahead and configured the area 1 as a totally stubby area. All right, thanks for watching, and I will see you Monday.